Welcome, dear students. Welcome to the chapter of chemical kinetics. Today, here in this chapter, we are going to learn about the different changes occurring in a chemical reaction and what are the different rates and other factors which influence the kinetics of a chemical reaction that we are going to learn today in this chapter. So you all know that chemistry by its nature, it is always concerned with change. Means anything in chemistry that you come to see, you will always it will always accompanies a change, like from A to B. There is a change which is always seen in case of a chemical reaction. Without this change, there is no chemical reaction ever observed. So here in this chapter, we are going to learn that why some reactions occur very fast, why some reactions occur very slow, what are the properties which determine this one. We are going to learn about this today in this chapter. So now, suppose if I am showing it with the help of a GIF, you see this at this is a reaction which is given. Suppose you see the mixing of all the four things. It is happening in at equal time. At the same time, all happen. But the reaction that started, you see there is a delay in the time. So now, what are the factors which influence this? That is, we are going to understand in this chapter today. Let's start. So for a chemical equation, chemist, what he or she determines first, or what he tries to find out first. First thing what he tries to find out is the feasibility of a reaction. Feasibility of a reaction means whether a reaction will occur or not. Means if a substance is A is there, whether in a due course of time, whether it will change to A to B or not. That is the first thing that a chemist finds out. The next one is that if the reaction occurs, to what extent it will occur. मतलब अगर ये reaction हुआ तो कितना A B तक बदलेगा और कितना A का A ही रह जाएगा. मतलब कितना चीज change होगा और कितना चीज change नहीं होगा. That is the second thing with a chemist is to find out. And the last one is the speed of a chemical reaction. मतलब A से B तक अगर change हो रहा है, then what is the time required for the change in A to B? That is the third thing what a chemist tries to find out for a chemical reaction. तो अब केमिकल रिएक्शन का वो ब्रांच जो रिएक्शन रेट और रिएक्शन मैकेनिज्म के बारे में पढ़े, मींस दैट ब्रांच ऑफ केमिस्ट्री व्हिच स्टडीज अबाउट द रिएक्शन रेट एंड देयर मैकेनिज्म, दैट इज नोन एज chemical kinetics. That is this chapter. So now here we will be knowing about the rate of a chemical reaction. Just as you know that speed of a suppose vehicle or speed of a car, suppose if you see that speed of an automobile, it is expressed in terms of change in position or distance which is covered in a certain period of time. Similarly, the speed of reaction or rate of reaction, it is defined as change in concentration in unit time. मतलब देखो, this is suppose अगर मान लो एक general reaction है मेरे पास, suppose here the reaction which is considered, let us consider that R is changing to P मान लो. तो जैसे जैसे समय पास होगा, व्हाट विल हैपन एज द टाइम विल चेंज. मान लो स्टार्टिंग में टाइम टी था, इट चेंज्ड, और अब डेल्टा टी टाइम के बाद कुछ एक चेंज हुआ और जो आर था वो पी बन गया. तो एज टाइम विल प्रोसीड, व्हाट विल हैपन, द कंसंट्रेशन ऑफ आर इट विल डिक्रीज और पी का जो कंसंट्रेशन है वो धीरे धीरे बढ़ता चला जाएगा, बिकॉज रिएक्टेंट इज चेंजिंग टू प्रोडक्ट. सो एज time will proceed, what will happen that your reactant will decrease and your product will increase. So what will increase of the reactant? The concentration. The concentration, if you remember, third bracket, the square bracket represents the concentration. The concentration of R will decrease and the concentration of your product, it will increase with time. It means that this concentration of R, it will have a negative value, and as your concentration of P will increase, as your concentration of P will increase, तो P का जो वैल्यू है वो तुम्हारा पॉजिटिव होता चला जाएगा एज द रिएक्शन विल प्रोसीड इन टाइम. तो अब रिएक्शन का रेट कैसे लिखते हैं? हाउ इज द रेट ऑफ अ रिएक्शन रिटन? सो रेट ऑफ अ रिएक्शन कैन बी रिटन इन टर्म्स ऑफ द रेट ऑफ डिसअपियरेंस ऑफ आर. मतलब आर किस तरह से खत्म हो रहा है, मींस व्हाट इज द चेंज इन द कंसंट्रेशन ऑफ आर इन टाइम टी, या फिर what is the increase in the concentration of your product in time t. That is how your concentration, how your rate of a reaction is expressed. तो rate of a reaction को express करने के लिए हमें reactant चाहिए, साथ ही product चाहिए. reactant जो है उसको square bracket में इस तरह से करके लिखा जाता है, product को भी square bracket में इस तरह से करके लिखते हैं, and in the denominator we used to write the change in time, which is your delta T, and in the numerator we have to write the change in the concentration of either your product or your reactant. If your reactant is changing, you have to write it negative because ये decrease हो रहा है reactant और product increase हो रहा है, इसलिए product को हम positive लिखते हैं. Further one more it is given here. देखो जैसे ये है rate of appearance of P, जैसे increase in the concentration जो मैंने बोला कि delta P by delta T. तो डेल्टा पी जो है वो चेंज इन द प्रोडक्ट है, डेल्टा पी इज योर चेंज इन योर प्रोडक्ट, बाय डेल्टा टी इज योर चेंज इन टाइम. और क्योंकि ये कंसंट्रेशन है तो कंसंट्रेशन लगाते हैं, और क्योंकि आर इज चेंजिंग टू पी मीन्स योर आर इज रिएक्टेंट एंड पी इज योर प्रोडक्ट, so this product it is positive value and that is why this positive is given here. In this case here this positive is present. Now the next thing is that just keep in your mind that rate is defined as change in the concentration by change in the time. तो यूनिट्स क्या होंगे इन रेट ऑफ रिएक्शंस के, देखो ऊपर हम क्या लिख रहे थे, कॉन्सेंट्रेशन. सपोज ऊपर हम लिख रहे हैं कॉन्सेंट्रेशन ऑफ प्रोडक्ट रिएक्टेंट सपोज, तो आर लिख लेते हैं बाय चेंज इन द टाइम. तो इन शॉर्ट अगर हम बात करें, ऊपर हमारा कॉन्सेंट्रेशन है और नीचे हमारा टाइम. इट इज आवर टाइम मीन्स डेल्टा टी इज टाइम, सो कॉन्सेंट्रेशन विल बी टाइम. So the unit of any rate of reaction is expressed as concentration per time. अब ये जो concentration है ये अगर liquid substance है, अगर कोई reaction तुम्हारा liquid में हो रहा है then the concentration is given in terms of mole per liter. और अगर कोई gaseous substance है, if it is gaseous तो ये दिया जाता है atmospheric pressure के term में, जिसको हम ATM के द्वारा बताते हैं. अब time, तो the units of time it is already known to you. टाइम जो है वो सेकंड हो सकता है, इट कैन बी आवर, इट कैन बी मिनट, इट कैन बी ईयर्स, ये सब टाइम हो सकता है. तो अब यूनिट्स ऑफ रेट ऑफ रिएक्शन जो है वो कंसंट्रेशन पर टाइम होता है. तो कंसंट्रेशन पर टाइम मतलब इट कैन बी मोल पर लीटर पर सेकेंड, इट कैन बी मोल पर लीटर पर आवर, इट कैन बी मोल पर लीटर पर मिनट, मतलब कुछ भी इस तरह से. और अगर gaseous substance हुआ so it can be atm per second, it can be atm per hour, it can be atm per minute. So this is how the units of rate of reaction is expressed. So now we will be proceeding to certain specific reactions, that how a rate of a reaction is written. जैसे ये देखो, ये units of reaction के बारे में जो मैंने बोला वहाँ पर, ये units of the rate of a reaction it is expressed in terms of this one, it is expressed in terms of concentration per time. तो कंसंट्रेशन पर टाइम, कंसंट्रेशन जो है वो मोल पर लीटर में होता है. मींस व्हाटएवर आई हैव सेड दैट इज गिवन इन योर बुक, यू कैन सी इट फ्रॉम द बुक आल्सो. नाउ वी विल बी प्रोसीडिंग टू सम सर्टेन स्पेसिफिक एग्जांपल्स वेयर वी आर गोइंग टू सी दैट अगर एक जनरल रिएक्शन है तो उसका रेट हम कैसे लिखेंगे. सो नाउ इफ यू हैव अ जनरल रिएक्शन, सपोज A moles of A plus B moles of B, and this is changing to your C moles of C plus D moles of D. So now it is said that you have to write the rate of this reaction. तो rate, अब rate के बारे में मैंने क्या बताया कि जो भी कुछ मेरा reactant है, whatever my reactant is present, that reactant we used to write it using a negative sign. तो सबसे पहले negative लिखो. After that whatever the coefficient you have, ये coefficient आ जाएगा denominator में इस तरह से करें. And your molecules of A were reacting, तो concentration of A लगाओ. And now there is a change in the concentration, तो इसको बनाओ delta by, and this occurs in time, it occurs in time, so it is delta T. फिर again equal to, again there will be a decrease in the concentration of this B, so it will be minus 1 by B again there will be a change in the concentration of B, so this will be delta B by delta T, then again you will be equal to, then now we are coming to the product phase. तो product phase में ये negative sign नहीं आएगा because there will be as जैसे जैसे time बढ़ेगा ये increase होते चले जाएंगे. तो 1 by C change in the concentration of your C by delta T and equal to 1 by D change in the concentration of delta D, sorry ये delta बाहर होगा, delta D by delta T. So this is how the rate of a reaction is written. Now this was for a general reaction where AA and BB, CC, DD were taken. Now I am going to take a general example. Suppose this is H2 plus Cl2 and this is becoming HCl let me balance this, so it will become 2HCl. So now we are to write the rate for this reaction. तो देखते हैं rate of this reaction क्या होगा. तो rate होगा rate will become, rate is equal to, since there is no coefficient here, so it will be direct minus change in the concentration of H2 by change in time equal to, again this chlorine is in the reactant phase, it will be minus change in the concentration of Cl2 by change in time, then again equal to, then now here in the coefficient you have your 2, so this 2 will come as 1 by 2, and change in the concentration, this will be change in the concentration of your hydrochloric acid by change in time. And this is how the rate of a reaction is written. If I take another example, then another example is, suppose you have, suppose Hi, and it is decomposing to H2 plus I2. If I am balancing it, it will become 2 here. So now we have to write the rate for this one. So rate will be equal to 1 upon 2 change in the concentration of Hi. So we have to mark change. So here it will be delta by change in time, that is delta T. And since this was present in the reactant phase, so one negative will come here. This will be equal to, no coefficient this time, so directly change in the concentration, so delta H2 by change in time is equal to change in the concentration of I2 by change in your time. And this is how the reaction rate is written. So many examples are furnished in your book. Now here some questions are there in your book that we will be solving in the next video. So now I'll tell you that what are the factors which means on which the rate of a reaction is dependent. Means what are the factors that influence, factors influencing the rate of a reaction. Now what are the factors which influence the rate of a reaction? So there are 3 factors which influence the rate of a reaction. The first one is concentration. Concentration का मतलब है कि कोई भी चीज कितने क्वांटिटी में लिया गया है. The quantity, that is the first thing which affects a reaction. Okay. Second thing is your temperature. मतलब जैसे जैसे तापमान बढ़ेगा, means temperature, as the temperature will increase, what will happen to the reaction? So here temperature, normally हम लोग डिग्री सेल्सियस या केल्विन में बात करते हैं. And the last one is your catalyst which initiates the reaction. So these are the 3 parameters which affects the rate of a reaction, means whether a reaction will be speed or slow, that is dependent on these 3. So we have to study this one by one. Firstly the concentration, then the temperature, and the catalyst. So about the temperature, about the concentration, it is a very vast topic. This concentration is the vastest one here, and this temperature and catalyst, they are short topic in this chapter. So we will be starting the next video with this dependence of rate on concentration, means how this concentration affects the rate of a reaction, that we will be studying in the next class. So ending the video here, and thanking you all for watching the video up to here. So thank you very much, and have a good day.